Unit 6 Study Guide, Part 1, Number 3. Number 3 asks us to solve the following system both graphically and algebraically. So I'm going to go ahead and do graphically first, and I'll do graphically here. So we have two equations given, and we kind of have to understand which one is which. So if I'm looking at this top one here, because this is x squared, we know that that's going to be a parabola, right? That's a quadratic function there because we have an x squared. If you look at the one on the bottom, this equation here, because this is just x, we know that this is going to be linear. So let's start off with graphing our quadratic function. So remember step one, and this is on the board in the classroom as well. Step one is whether your graph opens up or down. So if we picture this, if we look at A is equal to 1, which means our graph opens upward. And then second, step two is finding the vertex, right? We use negative b divided by 2a to find the vertex, and we plug into it. So negative b, so the negative from the formula. B is negative 6, right? And this is A, this is B, this is C. All divided by 2 times A, which is 1. So simplifying this out, negative 6 times negative is a positive 6, 6 over 2. So we're looking at 3 for the x value of the vertex. So we're almost done with the vertex. We need to find the y value now. So far we have the x, 3 is x. To find the y value, we take our 3 and we plug it back into our equation here. So we have 3 squared minus 6 times 3 plus 2. This is 9 minus 18 plus 2. 9x minus 18 is negative 9 plus 2. We're looking at negative 7. So our vertex is at 3, negative 7, right? That's the x value. This is the y value after we plugged it back in. So vertex is 3, negative 7. We plot that point in. And then we know that the axis of symmetry goes down the middle. This is the line that splits our parabola in half. Next, we find our y-intercept. And anytime you want to find intercept, you're plugging in 0. And again, we plug in 0 for the equation there. So we get 0 squared minus 6 times 0 plus 2. That cancels. All we're left with is 2. So for our y-intercept, we're looking at 0, 2. 0, 2. There's our y-intercept. And then we reflect this point. That's 1, 2, 3 away from the axis of symmetry. So then 1, 2, 3 away on the other side. We are looking at our free point. And then finally, the last step is to find our strategic point. I'll do it in this little corner here, strategic point. And we can plug in any value that doesn't have a dot on it already, that doesn't have a y value. So for now, it looks like 1 is open, 1 doesn't have any dots on it, so I'm going to plug in 1. So we get 1 squared minus 6 times 1 plus 2. That's 1 minus 6 plus 2, and it looks like that's going to be negative 3. So my strategic point is 1, negative 3. 1, negative 3. There it is. And then reflect it. 1, 2. 1, 2. So there I have my parabola. Right, so we graphed our parabola, and now we can graph our line. So if I'm looking at our line, the bottom one here, remember that y equals mx plus b. All right, and this has been reviewed over and over again. B is our y-intercept. M is our rise over run. So if we're looking at this, our y-intercept here is, looks like negative 4. That's our y-intercept. So on this y-axis here, we're going to start at negative 4. And then we look at our slope. The number out in front is 1 over 1. So from there we rise 1 over 1. So up 1 over 1. And that's our second point. Notice that right there we had an overlap. We know that's going to be one of our solutions. So if we keep this up 1 over 1 going, we notice that we get another solution right there. So if I draw this line in, I'm going to try to draw it as straight as possible. We notice that we get two solutions. We have a solution here at 1, -3, and we have another solution here at 6, 2. Okay. Now performing this algebraically, and I'll go ahead and I'll do it here. So algebraically is going to require, it's not going to require graphing, it's going to require us to do a lot of following the PEMDAS rules to solve it. So notice that these are both y equals, and since they're both equal to y, what we can do is set these two equations equal to one another. So we'll have x minus 4 is equal to x squared minus 6x plus 2. Now what I want to do is make this equal to 0 so I can use factoring to solve for my solutions. I notice that my x squared here is already positive, so I don't want to move it. So what I want to do is I want to move these two terms over to the right hand side. So I'm going to subtract x on both sides, and at the same time I'm going to add 4. So I did 2 steps in one there. These cancel out, they're left with 0, so we get 0 equals x squared minus 7x plus 6. So now that a is 1, we can go straight to doing our diamond method. So what multiplies up to 6 and adds to -7? We're looking at -6 and -1. So our two factors, x minus 6, x minus 1 equals 0. So now if we take x minus 1 and x minus 6 set it equal to 0, x minus 6 set it equal to 0, x minus 1 set it equal to 0, right? We add 6, add 6. I'm running out of room here, but we get that x equals 6, and on this side here, we'll ultimately get that x equals 1. So our two solutions. So if we're looking at these and we go back to the graph, when x was 6, we had a solution there. And when x was 1, we had a solution there. So if we wanted to double check to see what the y values were, if I plug in 6, right, so if I'm looking at x equals 6, if I plug in 6, 6 minus 4 gives me 2, 6 comma 2. That's that point right there. And if I plug in 1, I get -3. So 1, -3, that's that point right there. So just to confirm, 2 ways to do it. You are expected to know how to do both ways on your test.